Hello, Algebra 2 students. Today we're going to start looking at parabolas and specifically how to graph them with transformations. So we're going to come back to one of the most important overarching themes of our class, which is how to graph any function from the library of functions with transformations. So before we went ahead and did that, I thought we'd just go back to the most old school, the most basic way of graphing a function. So I picked a parabola here, and we're going to plug some inputs into that parabola. These are kind of randomly chosen. I kind of picked some good inputs to show the most important features of the parabola as well. So let's go ahead and plug them in and graph a parabola by plotting points. That's of course not the most efficient way to do it, but I did assign you a couple of those just so you appreciate the power of transformations. And because we could always use more practice with order of operations. So let's go ahead and plug -5 in here. So -5 squared minus 3 times -5 plus 4. Okay, so if you were following me and you think everything's good to go at this point, you might want to take another look. I've made an intentional mistake, and it's one that you're going to make if you're not very careful when you're working with Algebra 1 or Algebra 2, and that is ignoring a double negative. You can see that -5, the whole -5, is supposed to be plugged inside the x. So we should have a negative on the inside and the outside. Let's try that one more time. Here we go. Hopefully not making a mistake this time. So I've got negative from the function, then I'm inputting -5 into x, then I've got -3 from the function, I'm inputting -5 again, and I'm adding 4. So you can, of course, simplify that. I'm just going to do some scratch work off to the side on some of these. That's going to be -+25 plus 15 plus 4. So that's going to be -25 plus 19, which is going to be -6 for the y value. Whoops, and I want to write these as coordinates, so -5 in, -6 out. Okay, I'm going to alternate colors here just to clarify. So we've got -4 that we're plugging in. So I'm going to plug in -4 like so. And if you'd like to fast forward the video at this point and just see what the solutions are because you're comfortable with order of operations, go ahead and do so. I'm going to actually show all these calculations for anyone that feels like they need them. So that looks like -16 plus 16. That's going to give me a y value of 0 when I plug in -4. Okay, go back to blue. -3 squared minus 3 times -3 plus 4. I'm going to see if I can show that in here. So it's going to be -9 and then plus 9 plus 4. So that's going to be a nice 4 when I put -3 in. And so forth and so on. So when I put -1 in, it's going to be -1 plus 3 plus 4. That's 7 minus 1, which is 6 when I put -1 in. And I'll put 0 in. So let's see, that's going to be 4. You know what? I'm not even going to show my work there. That's easy. 0 and 4 when I stick it here and here. And we'll do one more. I think that might be enough. Let's go ahead and plot these at this point and see if it's enough. We'll do one more. So negative. Oh, you know what? I'm supposed to be green. Let me be consistent. So negative, we're going to plug 1 in and square it. -3 times 1 plus 4. You have to forgive my handwriting today. I have a thumb injury. So I'm going to plug 1 in, and that's going to be -1 minus 3 plus 4. That's 4 minus 4, which is 0. All right, let's go ahead and plot these points and see if we can get anything out of this. So -5 for x and -6 for y. There's one right there. -4 is 0. -3 and +4. Okay, and then 0 and +4, okay, and then 1 and 0, okay. I think that's not quite enough points. Maybe I should plug in 3 and just have one more look. So -3 squared minus 3 times 3 plus 4. What's that going to be? A -9 plus 9. Oh, nope, I made a mistake. It's -9 minus 9 plus 4. So that's going to be -8 14 plus 4, which is going to be, so when we put 3 in, we're going to have negative 14 out. So 3 in, and it's going to be way down here. Okay, I think I can see the pattern of this parabola now. It might be a good idea to stick, oh, we did have one more. I skipped one. Negative 1, 6. That's going to help the pattern right there. Okay, I think I can see this parabola now. It's going something like this, that way, and something like this. If you can forgive my rough handwriting there. That way. So that's a pretty terrible parabola that I've just drawn, but you get the idea of plotting a parabola one point at a time. A pretty tedious process. So let's go back and look at our transformations again. We want to go back and grab our transformations sheet, or at least remember the main theme of transformations. That theme being inside transformations are always going to be horizontal, or of a horizontal kind of phenomena or persuasion, and they're going to be the opposite basically of what you'd expect to occur. Outside transformations are always going to be some kind of vertical transformation of the image, whether it's a reflection, a shift, or what have you, stretch. And they're going to be pretty much exactly what you expect. So let's write down what kind of transformations we have here, remembering that we've already done this once before. So plus 2 should be 2, and since it's outside, that's going to be up, right? Okay, so then that's going to be 2 up, and then this guy inside right here, that's going to be 7 to the right. So remember, inside is horizontal, and it's opposite of what you expect. You might expect minus to be to the left, but it's opposite since it's inside and horizontal, so it's going to be 7 to the right. So g of x is going to take our normal parabola. Now your normal parabola, I'm just going to graph on this one just for reference, is going to, of course, be this parabola. It starts at the origin, and it's not a V shape. It should be a nice U shape. So there's f of x equals x squared. So we're going to take that parabola and we're going to shift it to become g like this. So it's going to go 2 up. So right here the vertex moves, it translates 2 up, and 7 to the right, and nothing else happens. So it's going to be something like this now. I didn't do any kind of stretching or anything like that, so that's g. There we go. So let's do another parabola. So this time, again, we're going to take f of x. You know what? I'm just going to draw g each time this time. So minus 5 is outside, so that's vertical, and it's going to be down, just like we expect. Plus 3 is inside, so that's opposite and horizontal, so we think right, but it's actually going to be left by 3. And then right here, this minus out in front, it's out in front, right? So it's outside. So that's going to be a vertical or an upside down reflection or flip. So I like to say vertical reflection. Technically, that's of course going to be over the x-axis because this is the x-axis. Okay, so we're going to go down 5, so like so, to the left by 3, so there's our vertex, our new vertex that's been transformed, and instead of going up both ways, we're going to go down. So this one's going to cross the y-axis, so I also want to calculate the y-intercept. Let's go ahead and do that. So the y-intercept is, of course, where you hit the y-axis, so that's going to be where you plug in, where 0 produces, whatever the y value for 0 is. So I'm going to do that one right here. And just make sure for all order of operations, so inside first makes that 3. Then I have exponents, that's going to be negative 9 when I square 3. And then finally I can subtract and say that's negative 14. So the y-intercept is going to be way down here, just like we expected because we knew that this was flipped over vertically. So it's going to be something like this. And that provides a nice scale for how wide the parabola G should be. One other thing I want to note, so let me wipe out a little bit of this right here, is that you can actually make that inside is opposite rule a little bit more digestible if you transform it like we did with some other algebra this year. What I mean is, instead of saying x plus 3, this could of course be written as x minus a negative 3, and then you can clearly see the idea of this negative 3 when you read this as the distance x minus being the distance between the x's you want and -3. So just remember that idea of you've kind of got a double negative built in. That's the idea of why horizontal types of transformations are opposite of what you expect. So I just thought that might be a nice review item to bring up once more in parabola land, like we've now entered. Let's look at a couple more examples. And we can, of course, pull out our calculator to help us with these. You are, of course, responsible for being able to do any of these problems without a calculator, but it's nice to bring your calculator into the mix as well to get more experience with it, as well as to refine your understanding of transformations. So here we have -1 on the inside again. So what does that do? And I think at this point maybe it might be a great idea to pause and maybe try 3 and maybe even 5 out. Or you can pause when we get to number 5 here in a moment and try that out yourself before I do it with you. So what does -1 on the inside do? Well, it's inside, so that's got to be horizontal. So I'm going to go right by 1 because that's what minus inside does. Outside we've got a negative, so we're going to say, I'm just going to say bullet point here. So I think that's going to be a vertical flip once again. Vertical reflection. I'm just going to say flip for short this time. And what does this 1/2 do? So that's also outside, so you know it's going to be vertical, right? So it's going to be vertically stretched or compressed. So if you take each y value or each g of x value and you cut it in half, is that going to smash your curve vertically, or is it going to stretch it out and make it steeper vertically? I think, of course, this is going to be a vertical compression if you just use common sense. And since it's vertical, you can use common sense. If it was horizontal, you'd have to think opposite, right? Okay, so we know our curve is going to be a little bit flatter than usual. We know it's going to be to the right by 1, so we're going to have a new vertex right here. And we know it's going to be flipped over because of the vertical flip. So it's going to be something like this, right? Something like that kind of parabola. Let's plot a couple points to make it real clear here. And on most of your problems, I'd really like you to plot some points. This is a great example of where you need at least a couple points. We could go ahead and find the y-intercept again. That might be helpful. We could plug in 0, in other words. And so that would be -1/2 times 0 minus 1. So that would be -1/2 times -1 squared, which is just 1. So it's going to be -1/2 times 1, which is -1/2. So not very high right there. We could, of course, also plug in another y value and see how far we'll be out. Maybe we should plug in like -4. So I'm going to go over here and plug in -4. It's going to be -1/2, -4 minus 1 squared. It's going to be -1/2 times -5 squared, which is 25 times -1/2. So that's going to be like -12.5. Okay, so at -4, we're way down here, and you know what? I'm going to just stay consistent with blue on these. -4, we're down at -12.5. So you can see that even though this flattened out, parabolas still kind of go pretty steeply. So it's flat at the beginning, but then it's going to turn around like that. So let me try to get a nice mirror image over here. Okay, so there's another example. Let's look at number 4 now. So in number 4, we just have one transformation, just this 4 dude right here. So is he inside or outside? Well, of course the 4 is inside. So that means it's horizontal. Now this is one of the trickier kinds of transformations, which we want to start getting better at since this is our second go around with transformations. So 4 is inside, so we know it's going to be horizontal. So this might be, you might be thinking is a horizontal stretch because it's times 4 on the inside. So I'm going to write that out, horizontal stretch. Okay, so how do we do this? Well, if you remember, my sheet had this little tip on it. It said g of x is going to be like f of x divided by b for when you have horizontal stretches or compressions. That might help you. I think the reason here is that this is basically the same thing as plugging in 1 divided by 1/4 x squared. Now you might be saying, well, of course, why am I making this so complicated? Well, because if you divide by 1/4, it flips with copy dot flip and becomes 4. I think the real factor here is that this is not a horizontal stretch I think, in fact, it's actually a horizontal compression. Maybe we could see that by just plotting a couple points like we've done on some other examples. Let's just go ahead and plug a couple values in. For instance, let's plug in 1. If we plug in 1, then we're going to have, what, 4 times 1 squared? Well, that's going to be 4 squared, which is going to be 16. So at 1, we're already way up at 16. I know that's not quite 16. And same thing for negative 1. If you plug in negative 1, it's going to be 4 times negative 1 squared, which is going to be negative 4 squared, which is also going to be 16. And that's what I went ahead and plotted here. So you can see that this is clearly not horizontally stretched. Still going to go back down to the origin. But it's clearly very, very steep. And if you think horizontally, that's basically a horizontal compression. It's horizontally compressing the two sides in and becoming very steep. So why does that make sense? This is not a stretch. This is a horizontal compression. Well, it's because of exactly what I said. Inside is opposite. Let me erase some of this business right here and get back to that main point. It's going to get all of this out of the way for us. When we think about this parabola, we've got to think opposite because any transformation inside is opposite. So you might be thinking times 4 is a stretch, and that's really good instinct. That's good intuition. But you remember, inside is opposite. So it's not times 4. Times 4 inside is actually a compression, and you can clearly see that when you plot a couple points. Another way to do this particular problem is just to simplify it. You could say that g of x is actually equal to, since there's just a couple things inside and they're multiplied, you could just square them both and say, well, really that's going to be 4 squared times x squared. So really this is 16x squared. And then you can think about that 16, since it's outside the squared now, as a vertical stretch. And this is clearly a very steep vertical stretch. It's being pulled upwards quite steeply. So you can change that horizontal compression or stretch on this problem only, or in some like it, to a vertical phenomenon to make it a little easier to understand. But it's also pretty important to be able to deal with horizontal problems. Let's look at another one, and this would be a great opportunity to pause and try it on your own. I think g of x on number 5, contains a sneaky transformation. So remember when we were doing absolute value transformations, when you had a sneaky transformation, that's when you have more than one transformation on the inside, and you need to factor to clarify those transformations. So I'm going to factor before I even start this one. You know what? I'm going to do it in black. I'm going to factor on the inside. Those, the 2x and the 6, in fact, share a 2. So I'm going to pull that out and see what's left. I think I'll have x and then 3 left, and then the squared, and of course any other transformations that happen to be there. So that really clarifies for me what kind of transformations I have on this problem. I think it's going to be down by 2. It's going to be vertically reflected again. Looks like another one of those. Vertically flipped because of the minus out here. So we've taken care of that. We've taken care of this. Plus 3 inside is going to be left by 3 inside. And then we just learned that inside, if you have times 2, you expect it to be a stretch, but it's going to be opposite. So we should have a horizontal compression. Now this time, instead of trying to draw this freehand, I think we're going to go to our TI calculator and make sure that it's doing everything we expect it to do. So let me grab my calculator here, and we'll have a look at it. So here we go. Let's go to y equals and graph this guy. And you know what? Let's pretend that we didn't even know about the sneaky transformation. Let's just graph the original one and see if it does what we thought it would do when we factored it, which is the only way to really clearly see that. So I'm going to go negative, using my small negative for something in front, and punch in 2x plus 6 quantity squared minus 2. Okay, I'm going to hit zoom 6, and there is my graph. So let's see if it did what we expected. Well, it's down 2, looks like that. It looks like it's flipped over, that's clear. It looks like it's left by 3, right? 1, 2, 3. We could, of course, trace on it here and have a closer look at that, but Yep, looks like about left by 3, and it does look steeper. I mean, if we didn't have it like that, we could compare. We could throw another graph in here. Let me pull that up a little bit just to compare to see if it is actually a little bit vertically steeper, or in other words, horizontally flatter. That's a hard way to think, though. If we just left that 2 out and went x plus 3 like so, and squared it and went minus 2, would it be a little bit wider? Yes, it would. So you can clearly see that horizontal compression pushing it in from the sides, or in other words, vertically stretching it. Okay, so watch out for those sneaky transformations. Let's look at a couple more problems before we quit this time. So in this one, in this assignment, you'll also have some problems where you're given a verbal description and you then have to proceed to writing a function. So I'm going to find a new function, g of x, that does these three transformations. I'm going to move it right by 8. Okay, let's just try to do them one at a time and make sure you do them in order. I think order might matter. We'll have to see as we continue exploring our library. But anyway, right by 8. So that's going to be inside. Minus 8, and I'll put my squared on because it started out as x squared. Okay, up by 3. That's easy, just put plus 3 outside. Vertically stretched by a factor of 5/4. Well, vertically stretched is outside, right? So it's outside and what I expect. So I go out here and put a 5/4 times it because that stretches it, right? I think that's mostly correct, but you're not really stretching the whole thing if you do it that way. So make sure you stretch the entire original function. You're going to do that by adding one more set of parentheses and distributing. So let's go ahead and distribute that 5/4 to get our correct final answer here, which is going to be this guy squared plus 5. You know what? Let's do some scratch work on that instead. 5/4 hitting the 3. I think that's going to be 15/4 now, right? If you go over 1 like so. So that's the final answer of that one. And of course, you should also be able to identify a function from not just a verbal description, but from a graph. So I've got this purple function here. Let's have a look at this guy. I guess I'll get a purple color to match. All right, so what is our new function this time? G of x is going to be what? Looks like this has been moved to the left by 4. I see the vertex right here, so I'm going to say x plus 4 inside. Get my squared going, okay. It's negative because it's been flipped over, so I'm going to put a negative outside. And, oh yeah, it's gone down a certain amount. Looks like down by what we have here. It looks like 3 about, so I'm going to say minus 3. Might want to try that one on my calculator now and just see if I did it right. This might be a good way for you guys to go about this. So let's clear out our calculator and just try this example that we had. So it was negative. I got to get that down there. Sorry. Negative. What do we have? X plus 4 squared minus 3. All right. Zoom 6. So let's see, y-intercept looks like it's about negative 11 there. I'm not really sure what the y-intercept is here. Maybe I should go to my window and go ahead and make it go smaller in the y, like 20. Hit graph. And let's see, well, what's my y-intercept here? I could always calculate it, right? I could hit second, calculate, and just hit a value and say x equals, let's say 0. Y-intercept. So y-intercept here is negative 19, right down there. Our y-intercept looks like it's like 11 or 10 or something like that. Something's not quite right here. Well, I don't know. We might have to put an a here in front and decide. So you know what? I'm going to say negative a and leave everything else. Maybe there's a stretch or compression factor, in other words. I'm not really sure what it is yet. Can we solve for it? Oh yeah, we could solve for it by doing that same thing, right? We could say g of 0 and plug in 0. You could, of course, just play around with this in your head, but I'm writing it down nice and formally here because we need to be able to solve problems like this. It looks like it's negative 11, so I'm going to say negative 11 is g of 0. And I'm going to simplify this side. Oh, that's 4 squared, right? So that's 16. I'm going to add the 3, and I can just really solve for a like this, right? I can just solve for a, and we should be able to get a. So this looks like negative 8. Negative a times 16. So that means a is negative 8 divided by negative 16. So 1/2, maybe it's compressed by 1/2 vertically. Let's try that. So I'm going to say my new g of x is going to be negative 1/2 x plus 4 quantity squared minus 3. Let's put that in our calculator and see if it looks better. Let's go and fix our calculator. So we got to put negative 1/2. So I want to insert that here. So I'm going to hit second insert. I'm just going to put 0.5 for 1/2. That ought to be pretty good. And let's go back to our graph and see if it's right. Yeah, that looks a little better, I think. If I go second, calculate value now, I can put in 0, and it comes out as negative 11, just like it was supposed to. So that is totally the correct answer. And I'm going to leave you on that problem today. So I hope you've realized how versatile function transformations can be in helping us graph parabolas now as our second or third member of the library of functions for this year. I'll see you next time.